Thank you for coming to the session. My name is Katarina Brookfield. I'm part of the technical marketing team in VCF division. With me, I have Jeremy.
Hi, I'm Jeremy Wolf. I'm one of the product managers on the automation team, primarily focused on declarative API and kind of bringing Kubernetes to your doorstep.
Yes. So what we will be covering today is 90 minutes of mainly demo. So hopefully you'll see how things work in real life. And what we'll cover, we'll start with kind of introduction to Kubernetes, but then we'll relate it to how we're implementing Kubernetes and cloud services in VCF. So let's go straight into that. First of all, our disclaimer slide, which I'm sure you have seen before during this conference. So let's open this up with when you're deploying an application. It's no longer just about deploying or finding a place for your application to run. Having a virtual machine or having a Kubernetes cluster is not really the end goal. It's all about the applications and what they need, especially in the ecosystem of cloud native and all of the tool sets that you are using in ecosystems. And that's why when you're deploying applications, it's all about all those supporting resources. Whether that's infrastructure, things like networking, load balancers, or storage, persistent volumes, but also all the other services that you need on your platform. You need to store your container images somewhere, so you need something like a OCI image registry, or if you want to bring any other functionality, like maybe some GitOps, or maybe storing or doing backups and restores and all of the services. So what we want to show you in this presentation as well is how do we take all of these services and apply it to a real use case. So what we will be doing here is we will be deploying a 3-tier application that will be using a virtual machine that we will configure with a MySQL database. And this application will also have a containerized backend API and frontend that will be running on a Kubernetes cluster that we will deploy with VKS. We will also show you how we will integrate some of the other services into this ecosystem, like, for example, one of our new ones, which is our secret store. So with that, let me give you a very quick, brief demo of what we will be deploying. So just a little sneak peek. As a consumer, I have logged into my cloud, and I can go ahead and start deploying my virtual machine. Using my user interface, I can go and do a full customization and deployment of the VM. I can then go ahead and create my secrets in the secret store that I will use to store my connection information. How do I connect to my database? I'll need a Kubernetes cluster, so I'll go ahead and deploy one. That's there, again, the same experience for every service available for me to deploy. And then once I will have a Kubernetes cluster, I will be able to go ahead and start deploying my application, starting with my backend and then also deploying my front-end containers, and lastly, logging into application. So this is kind of the end result. This is where we will get after 90 minutes. But what we want to show you is how do we get to this state? What do we have to do to enable all of these services on the platform? So let's go to the beginning. How do we start this? Maybe not as far as to the Big Bang, but let's start bringing some of the concepts together, starting with Hello Kubernetes. So what's that? Well, I won't go into all of the history. Let's start somewhere. But the idea of containers when it came was to create something that's really small and very efficient and bundling only the necessary information for my application, some OS, some dependencies for my application, and creating these small containers. And it was all great when we were only managing single containers, but when you get to a situation where you start deploying many of them, we came to a situation, as we did previously with virtual machines, where we needed some sort of orchestration. And that's really what Kubernetes is all about. Kubernetes is simply a container orchestration platform. It has been originally developed by Google, as many of you may know, and it brought all of these orchestration features to be able to manage our containers. Things like when you're deploying your applications, to be able to do it quickly, defining deployments, scaling up applications, rolling out new features, also doing scheduling operations and really, really quick restart. But also, main part of Kubernetes was this idea of the possibility to extend the API further from what you install on default and create these custom resources to bring new functionality into the ecosystem. So the first demo we're going to do in here is a very quick overview of Kubernetes. So we will just go through some very brief concepts. Let me just... and start doing that. So this is really just to introduce some of the basics for some of you that may be new to that. So in Kubernetes, we do have a Kubernetes cluster, and within that we have nodes. What we are working with the CLI is something that's called kubectl, or kubectl if you are one of those people. I prefer the other one. And you will see that we usually use the same set of commands, so I want to start doing that. So we get our nodes so we can see what's part of our cluster, and we can always use a describe command to describe a resource. So if you take a name of a resource, like for example, one of my nodes, I can get more information about what's there. So all of the annotations, the roles, the labels, some events, and all the configuration as well. So useful commands for all of the resources. We will be using this all the time, as you will see. So once we have our cluster, let's look at something else. Within a Kubernetes cluster, we have a concept of a namespace. And this is basically a logical isolation of a part of the cluster. And we can create our own namespaces and deploy applications into them if we want to. So in here, I've just created a namespace. And then I'm just configuring pod security policies to be able to deploy pods into this namespace. So I'm just doing that with the concept of a label. And now we can go ahead and start deploying things. So the smallest unit that you deploy in Kubernetes is called a pod. Usually pod has a mapping to a single container. You can have multiple of those. But just to keep it very simple, in this example, all we will do is take an Nginx container and wrap it into a pod. So I'm going to go ahead and deploy that. And we always use this kubectl apply command pointing to our manifest. So that's our definition of the resource. I'm going to go ahead and deploy this, and now I see my pod is running. Again, I can use the describe command to get some more information about this pod that I have deployed, including information about the pod itself, the name. I can also see the container information in there, some conditions, and also events. So it's always very useful to use this. What we can also do is, if I look at the pods that I have deployed in a wide view, I can see which node this is running on, for example, also its IP address. So let's explore kind of the behavior of a pod. So if I look at my nodes and I find the node where my pod is currently running, I can simulate the node failure. So what I'm going to do is basically put the node in maintenance mode. So I'll drain it and stop scheduling on it, because I want to show you the default behavior that will happen to a pod. So once I do that, I'm just going to drain the node. So we will see my pod was evicted. And now if I look for it, it's no longer there. And this is again because it was great, but it's pod, but it doesn't have any of that self-healing capabilities that we really want in Kubernetes. So what we need to do then is, instead of just deploying single pods, we can wrap it into something else. So the next thing we will be doing will be a deployment. Before I proceed with that, I'm just taking my node out of maintenance mode, which is the uncordon command. So now my nodes are back to ready to be used, and we can move on. So as I said, the next stage we would typically use is something that we call a deployment. And in here, we can define the number of replicas of those pods that we are deploying. So for example, here I'm deploying 2, but we can also bring in all of those cool capabilities of Kubernetes, like self-healing, like rolling updates, scalability, and all of that. So I'm just going to take that specification and apply that. And now that I deploy this deployment, it was created. If I have a look at that, again, I'm using the get commands to get information of what is deployed. I can see I have my deployment, and I do have 2 pods deployed. And if I check with the wide output, I can see that my pods were distributed across the nodes as well, so they're not running on the same one, which is always helpful. And now if I go and delete a pod, one of them, so I'll do that, what we will see is that it will self-heal. What does that mean? It will go ahead and deploy a new one. This is because I have defined that I want to have 2 replicas always running. So those are the safe self-healing capabilities of Kubernetes. So now, what's behind the deployment is something that's called a replica set. And that is showing you how many of those replicas you had in your desired state and how many are current. Let's move on to deploying something that's called a service. And this is basically something like a load balancer, or in this case, we will be deploying a type of a load balancer that will front our pods. And why we do that is because we can then distribute traffic into them. So I'll deploy a service. I will get an external IP that I can use to access this. So if I use this IP and I go to my browser, I will get to my Nginx. So I can reach it externally with this IP. But the main idea behind the service is that if I looked at endpoints, I will see what this is pointing to. So this is now where you can see there are 2 IP addresses pointing to my pod. But again, the really cool thing is that this is all dynamic. So if I, for example, go ahead and scale my deployment, so instead of having 2, I can go now to 4. I can use imperative commands just by scaling the deployment. In real life, you would probably want to just change your manifest to make sure your desired state is always kept safe. But I'll just very quickly scale this to 4 replicas. So now you can see I have 4 in there. And if I get pods now, I can see 4 in there with my IP addresses. And then if I look back at the endpoints, we'll see that now it's pointing to 4. So again, it's all about the dynamic distribution pointing to endpoints. So even if my pods are getting recreated, I know that my service object is there and that won't be touched, and it will be always dynamically pointing to my workload. So now I'm just going to describe my deployment again. And I can see all those events from history as well as it was scaling. So the describe command is really something you will see us use all the time because it's something that gives you a lot of information. What we can also do with deployments when we are deploying this is record the history of it. And what that allows us to do is we can then change, for example, pointing to a different version of a container, so a new version. I can go ahead and deploy that if I'm testing something. So I can change the version in my spec. And as I'm deploying this, I will record this. And what it will allow me to do then is when I look back at it, under my rollout status, I will be able to see the new version that was deployed. So we can see that it was rolled out. And if I look at the history of it, it will show me those recorded revisions that I have. And this is really useful because what I can do now is if, for example, I've deployed a new version of my application and something went wrong and I want to go back, I can very easily do that because the replica set that was in behind the original one is still there. So I will just very quickly switch back to the original one and switch back to the version. So again, just something that's very, very useful when you are in a really dynamic state of applications, deploying new versions all the time. So I can go back, undo that deployment by specifying where I want to go. So I have the previous revision. So up there we can see we were on version 1.24. Now we're going back. We can see we switched back to the original replica set. and then we're back to the original version. Okay, let's talk about storage a little bit, because as all of this is very ephemeral, we need to provide some data persistency. And we do it with something that's called a persistent volume. In Kubernetes, we have something that's called a storage class, which defines eventually where the storage will end or the persistent volume will end, and also its behavior. When should it deploy new things? So what I'm going to do is I will create something that's called a persistent volume claim, and basically say that, hey, I want a small chunk of my storage to be created. And the beauty of this is that the lifecycle of these resources is completely independent. So I can create a persistent volume. It's created there. We can see that it was bound successfully. And now I can go ahead and mount it basically into a pod. So we can see used by none. So at the moment it's there, it's created, but nobody is using it. So I'll take the name of that. And now I have a spec for a pod that has this attached. So I'm just going to provide the information into my volume mount. And what this will demonstrate is that now that I can go ahead and deploy a pod that will have access to this volume. So this way I can persist data in that space. So I'm just going to go ahead and deploy that. That's created. And we can see used by, now we see our pod is using it. And now if I go inside of the pod, which is something I can do as well with using the exec command, I can go directly into the pod. I'm just going to do that. Now I'm logged in. I can see where I mounted the volume. So I just go into the path and just check that it's there. So this way we can verify that we have mounted the volume, and I can create a file on it. So I'll just create like a file that's called test, and this will be then written into the volume. Now, again, as I mentioned, the beauty of this is that the kind of life cycle of this is independent. So what happens if I delete this pod now? Well, we'll see that if we go ahead and do that. So I'm going to delete the pod that I have just created. So it's deleted, it's no longer there. If I look back at that persistent volume claim, I can see again it's used by none, so no one is using it. And now if I redeploy the pod, which keep in mind will create another version, I can see that it has used that volume. And again, we can just verify that if I go back into that pod, that file that I have previously created is still there because it was persistent in the volume itself, not in the pod. So we can see my test file is in there. So that was just a very quick introduction of some of the very basic concepts of Kubernetes. Stop it. And now let's talk about how we brought this into VCF.
So how do we get Kubernetes, right? Like, we all want it. We want the kind of declarative nature that comes along with it. We want to be able to take advantage of all the cloud services that you guys have heard all through Explorer and the keynotes and everything. So, like, how do we do that? How do we bring Kubernetes into the VCF platform? So first, let's kind of think about what is Kubernetes. Like, what's the difference between Kubernetes versus this construct that we're calling the supervisor, okay? So Kubernetes cluster is made up of a control plane. This is where all of our like Kubernetes capabilities exist. So the API server. This is where etcd is, the database that stores the state of those of the workloads, the state that we expect to be deployed there. And then it's made up of worker nodes. Worker nodes are just the landing zone for the workloads themselves. So in the worker nodes, we have kubelet and we have the proxy. And this is what is going to allow us to deploy our containers there, have the container network in place, and then be able to actually deploy and leverage that ecosystem. And so we've taken this construct because there's a lot of greatness here. There's a reason why Kubernetes is so popular. And we decided, hey, if we are looking for these capabilities around declarative API, why create something on our own? Why don't we use something that has been time tested and is being used in a lot of industries? So we created the supervisor. And you'll notice a lot of similarity here, right? The supervisor also has a control plane. These are 3 virtual machines that we deploy as standard vSphere VMs. They have the same concepts around the API server, the scheduler. And we also then, we're going to talk about this in a little bit of detail in the next couple slides, is we leverage this concept of the operator custom resource definition pattern to extend the capabilities that exist in this ecosystem. And we'll see some examples and we'll see some demos of exactly what that looks like in the platform. But I want you to kind of latch on to this idea. That operator custom resource definition pattern is literally the power that we're going to use to bring in additional services into the private cloud and eventually give you the ability to bring your own services into your own private cloud so that it is all consumed through the same layer. You'll notice that our worker nodes here, we call them specifically, they're the ESX hosts. So what we do is we actually load a Spherelet, which is our own version of kubelet. We put that onto into the ESX hosts themselves, and that turns those things into worker nodes. And it's going to allow us to use a runtime we call vSphere Pod, and that is the primary container runtime that we're going to utilize for our container workloads that are running in the supervisor. So just to be clear, don't confuse that with the pods that would be deployed inside of one of these VKS clusters. And you'll see kind of these different elements in effect here in just a second. So let's talk a little bit about the operator and custom resources. So generally this pattern is we have an operator. The operator is, think of it, a codified, programmatic set of instructions that are going to take something that a human operator would typically do. Say, create something, lifecycle manage something, upgrade something, configure it, alter it, like it's things that a human being normally would do. But let's put that into some kind of automated process and let it execute that operation on our behalf. The operator is the way that we kind of turn standard services into managed services. So in this example, we then have a custom resource definition, and you can think of a custom resource definition as a extension of the API. So it is a, hey, here's an object. Here are the fields that I need and information you need to provide me so that the operator then can create an instance based off of whatever capability it is. So in this example, let's just say theoretically, we decided we're going to bring up functions as a service into the ecosystem. We create an operator that understands how to facilitate that operation, understands how to manage it. We then expose a custom resource definition for the API version fastvmware.com v1 alpha 1 and of kind function instance. Once that's exposed, I as a user can go into my consumer space and I can specify a YAML file that then gives me the ability to deploy that instance. So we always are operating off of this operator watches, sees the state that I expect, and then acts on my behalf to then create those things. Because this is declarative, because it's using the same API services, we're able to utilize things like GitOps. We're able to put this stuff in source control and be able to leverage it. And like I said, we will see this in action here in a couple minutes in the demo. So using this model, we actually are able to do something kind of interesting in the supervisor. If you ever have deployed Kubernetes, one of the biggest challenges is you need to put service accounts. You need to give access to the underlying infrastructure resources, whether it's vCenter, NSX, vSAN. You have to provide those service accounts. Those service accounts now are kind of in the cluster. That means someone else has access to it. So now typically you're going to need to deploy separate infrastructure in order to satisfy the fact that you don't want kind of a user the ability to kind of bleed into the ecosystem and, get access. But in our world, in the supervisor, we use this operator controller pattern to leverage this watch act update cycle so that in the consumer space, they're interacting with the APIs, but they're never interacting directly with the infrastructure behind the scenes. So we leverage our operators that we'll see in a little bit, VM operator, our Kubernetes operator, and we execute those operations on the infrastructure on their behalf. So when they request a virtual machine, we facilitate that ask and we go back into vCenter and we say, hey, we need a virtual machine. That virtual machine needs a NIC. That NIC is going to come from NSX. And we do all of this without that user ever having access or visibility into the underlying infrastructure. So let's kind of look at what is required to even get the supervisor in place. So there are multiple ways to enable the supervisor. What I'm going to highlight right now is kind of how we do this inside of VCF. So the primary flow is going to be the creation of the supervisor, enablement of the supervisor through workload domain creation. So I'm not going to kind of touch on a lot of the stuff in the workload domain creation flow. I hope that some of you have done this already because it's drastically improved in 9. But if for some reason you don't do this in workload domain creation flow, you always have the ability to go into vCenter, go into supervisor management and enable it through that flow. The inputs are generally the same, and the outcome will be exactly the same, that you have this supervisor declarative API service available to you. One thing I want to highlight real quick is that you'll notice on this screen, there is the Enable vSphere Supervisor toggle. It's currently toggled on, it's green. If you toggle that off, you will have none of the capability that I've talked about. It will just be straight up regular vSphere, regular VM ecosystem. You'll have none of the advanced cloud services. So I encourage you, as you're going through this process, ensure that you are enabling or leaving this toggle in place and providing the inputs in the following steps. So we're doing our vCenter, we're adding our cluster, defining our zone, selecting an image. So this is the first spot I kind of want to talk real fast. So we are going to deploy NSX when we're using the workload domain creation flow. This is primarily because we get some of the biggest value from the supervisor in the full VCF cloud space when we're leveraging NSX plus VPC. So we're going to do this, and there's going to be a couple of steps I want to call out that I want you to be aware of. First one here is going to be, you'll notice down here at the bottom, we have the configuring network connectivity that you can't see because the bar is in the way. Well, what it says in there is that we have the distributed gateway deployment and the centralized gateway deployment. And the key here is that when you enable the supervisor, we're going to automatically select that centralized connectivity model. And the reason we do that is because we need stateful network services, load balancer, NAT, SNOT. That stuff's not available yet in the distributed gateway model. So right now we're going to eventually have to go deploy an edge cluster, and we'll see kind of that flow. But I just want to call that out because it's an important thing to think about, because we do need those stateful network services so that we can get all the capability we talked about. All right, so this is the first area where we're actually going to start providing input for the supervisor itself. So when we're doing this, we're going to give it a supervisor name. It can be whatever you want it to be. No one is going to generally see this in the ecosystem. And then we're going to give a service CIDR. There are a lot of CIDR inputs here, and I want to kind of demystify and remove some of the fear on like what these things actually are. This first service CIDR is going to be a private IP range that is going to be utilized by the internal services that are running inside the supervisor cluster. They do not need to be routable. They do not need to be connected to anything. They just need to be unique. So you give a CIDR range here, and that CIDR range will be used for this internal purpose. The easiest way to deploy the supervisor is to continue to use your management network that you use for your ESX. And we require you to give us 5 IP addresses, sequential IP addresses. We're going to use these IP addresses as a constant network footprint for those supervisor control planes. We need 5 because we're going to use the extra for when we are doing upgrades so that we can roll out, because we do kind of a blue-green deployment of these control planes. And as we do that, we want to make sure we have the network identity in place. So 5 IPs. We're then going to use, so in this flow, we just automatically pick up the default project from NSX and the default VPC connectivity profile. This is because that was already created in the steps before, and we just want to get this started as quickly as possible. So this next input, this is the, I'm not sure if folks are aware of like VPC and the subnet constructs, but there's 3 primary routing modes. So one of the areas that we need is this private TGW IP space. This is going to be an IP space that's routable within the transit gateway. So think of it as the east-west traffic underneath that southern point of that TGW. This can still be a private range, and we're actually going to go configure it on your behalf inside of the transit gateway. We just need you to ensure that it's not being utilized anywhere else that has access to this transit gateway. The next field here is the private CIDR. Once again, it is another private CIDR range, but this one is going to be truly private. It's not going to be routable from anywhere. And this is going to be what we utilize for subnet creation that's going to be from a private perspective. So every time we create a VPC, we're just going to automatically leverage this private CIDR range and use it going forward. And obviously we need to set up DNS. We need to provide the NTP server IP. And at this point, we have provided all of the required inputs to be able to kind of complete this workload domain creation. So we're going to kind of review the inputs. And we're going to finish the deployment. Make sure you download that JSON, right? Because we don't want to go through this flow every time. So that way you can make alterations as you need to. So we'll finish it, and we're going to kind of watch this this task of deployment of the workload domain happen pretty quickly. You'll notice that we have kind of a checkpoint here, and it says, hey, supervisor is activated, but we need to go do one more step. Remember I was saying that we need to have a distributed gateway or an edge cluster deployed because we need these stateful network services. So we're going to go into NSX, we're going to enable that DVW. Once that's done, we're going to go back to vCenter. We're going to activate our network connectivity. And so at this point, we're going to deploy that edge cluster. So we need to be using that centralized connectivity model. So that is that standard edge cluster deployment. And so a couple of key things to call out here is, like, as we're filling out this information, we need to ensure that in the next screen that we are selecting the active standby mode. Sorry, I'm talking a little bit faster than the demo's going. Oh, wait a second. So at this point, when we select the high availability mode, we need to ensure that we select active standby. Active is not supported when you're deploying the supervisor, so make sure you are leveraging active standby. And then this VPC external IP block, once again, is going to be the public range that we're going to be utilizing for our load balancer service, and that will be then exposed into the supervisor for workloads to be deployed and leveraged from an L4 load balancing perspective. All right, now that we have the edge cluster deployed, we can go in and we'll actually see that the supervisor is now running and it is configured. So we are now ready to operate. We can deploy workloads. But let's look at what happens when we want to upgrade that supervisor, because it is an object we need to lifecycle manage here. So we have an asynchronous release cycle in 9.0 for the supervisor release itself. We are trying to decouple as much of the Kubernetes ecosystem from the infrastructure. So one of the final steps here was, let's grab the supervisor release and move it outside so that we have one that's embedded all the time, but we also have the ability to go grab it from a subscribed content library, bring it into vCenter, and then leverage it to upgrade so that we do not have to be moving vCenter quite as quickly as we would be moving the Kubernetes ecosystem. So at this point, we had already added it to the content library. We're going to go to updates, and we're going to click apply updates. It's always going to be a warning here to describe kind of what's going to happen. And you're going to notice that we're going to see a couple of warnings here. The one I really want to point out is the warning on the bottom. So when we do our initial deployment, we have one control plane VM that's deployed to try to minimize footprint size. That means that when we're doing an update, that one control plane VM is going to be replaced, and there will be a slight outage during that change, as we're flipping those IPs between the two endpoints. You can avoid this by deploying a 3 control plane deployment, which is something you can do day 2 in the supervisor configuration. So we'll execute the upgrade at this point. And you can see in the recent task, it was starting to update. We can see it's configuring, and we want to see more details on like actually what's happening, where in the upgrade flow we are. We go to the configure supervisor, we can kind of see those events as they're going. And one thing to call out is this, you see that current version over on the right side, v1.30.10. This is an important version to understand. It is typically when we release supervisor version, it's going to be that thing, that part of the version that is going to be changing. So if someone ever asks you what supervisor version you're running, this is where you get it, and that's the piece that you're going to reference.
Okay. Right, so now we've enabled supervisor. We need to expose it so we can start deploying our workloads. And the way we do it in VCF 9 is, as you have probably seen in other presentations, we now have a built-in multi-tenancy in VCF directly, and we have concepts of these regions. And what I really want to focus on here is really the relationship of the region to supervisor to be able to start deploying these workloads. So we'll have a quick demo for that. Just going to switch into that. And again, I'm not going to go through all of the details of the configuration, but just want to show you the relationship of supervisor in here. Cool. Okay, so I'm in my provider portal, and I can see that there's a region called Paris that is created there. And in that region, I do have a supervisor. So the supervisor was detected from the vCenter and then added to the region, and he absorbed all of the zones that it had, VM classes that the supervisor provides. So these are the kind of t-shirt sizing we use for VM hardware specification. Also storage classes, which define the data stores that we can use in these regions, and also then a concept of reserved VM classes as well. Then within an organization, where organization is a tenant in this world, we assign a region quota. So what I'm basically doing is saying that this organization can use this much of this region. So I'm selecting which region. So that's the Paris. I'm selecting the supervisor, the zones, and then also I can define the CPU and memory limits that will be assigned to this organization. So I'm going to go ahead and do that. Then I can select which of the VM classes will be assigned to this organization. I'm just showing you that in our user interface, if you want to select all, you have to go through and select them all. If you do the first page, you will only get 4 of them. So make sure you get all of them in that you want to configure. And then also you're defining, again, the storage policy, so which data store you are using, and giving an allocation to this organization. So for example, I'm saying out of all of my storage, I want to assign 600 gigs to this organization. So I'm just going to assign that and continue. Once the region quota is in place, my organization can start using it. So in here, I just have a user. And very quickly, we'll just go through these concepts. So now that we have a region for our organization, let's talk about how we are managing content in the organization. I'm specifically talking about images. So for that, we will continue in the content management. Okay, so the same space, I have my organization. I can go to the left side and I see content libraries. So we will have 2 types that are available. First one is a provider content library. So as a provider, I can create a content library, put the images in there, and all of my organizations will get access to it. So that's one that, for example, I have created there. And as always with content libraries, it can be subscribed, it can be local. I can decide how I do this. And now I'm going to switch into my organization. So I'm going to log out, and I have this organization called Broadcom, and I'm going to use my user to go in. So I'm going to log in. And in here, if I go to manage and govern, build and deploy, content libraries, I can also go ahead and create an organization level content library. So I'll create one for VM images. And the only thing I wanted to show here as well, and there's this toggle, that basically says, do I want to assign this content library to every namespace that I will be creating? So if you leave that as on, every namespace that you create within the organization will get the content library attached. This is really important because the images that are in the content library can be only used in the namespaces if the namespace is associated with that content library. I'm going to select the region where I want to create this one, and then just very quickly finish this. Once I have my content library, I can upload images into it. And I want to just very quickly show you that to deploy VMs here, you can grab any cloud image. We really do not have any kind of limitation. So for example, in here, I'm just grabbing Ubuntu cloud image. So you can just go, grab the standard cloud image, download it, and then we will upload it to the content library. And then we can start using it to deploy our virtual machines using this image. So, okay, now we have a content. Perfect. Now, another thing that we need to configure is something that we call a namespace, or vSphere namespace. And also I will show you how you then access this. And all of these things are things that we need to kind of configure to enable that consumption in this kind of order. So I just wanted to walk you through the steps. So now I will go ahead, and there's this concept of a default project, but I could create my new ones. I'm just going to utilize this for this demo, adding my user to have permissions to deploy everything in there, use the services. I'm going to create a namespace. And I'm showing you how this looks in that kind of consumption experience in VCF automation, but we will see what's on the background once we switch into the vSphere client. Because in here you can see that I have selected that's called something a namespace class that's defining like the sizes and the limits that are assigned to that namespace, which VM classes are assigned, and things like that. I'll show you how that translates into the infrastructure on the background, because as cloud admins, you're configuring the guardrails and the policies that are applied to these spaces for consumers. So I'm just going to go ahead and deploy that. And once my namespace is here being created, as I mentioned, if I go and look at my infrastructure in inventory, I will see the namespaces there. If you're not familiar with the term vSphere namespace, you can think of it as something like a resource pool. All we have done is that we have extended the capabilities to apply some other policies that are coming from that kind of Kubernetes space. So what you can see in here, if I go inside and manage it, we will see that we have that storage policy assigned there. We have that capacity that is coming from the sizing of that namespace class, and we also have some configuration of those content libraries. So for example, for the VM service to deploy VM images, because I left that toggle on to auto-assign to all of my namespaces, I have VM images, but I can also add the provider content library if I want to access all of those images in here. And once I do that, I have two. So that's just a very quick configuration of my namespace. Keeping in mind that everything you've seen that the configuration, you have to associate all of these objects with the namespace, because that what allows you to deploy all those objects. Now, how do I access this? Well, we do have a new CLI that I want to show you. But first thing we need to do is create an API token. So as my user, I'm just going to create a token and copy this and save it somewhere, because you will be using it all the time. Then I'm just grabbing a certificate of my VCF automation instance. And then what I'm doing is I'm just creating a context using this new CLI. So after I've done that, you can see that now I have access to the namespace that I have created. So I can use this to switch into that context and deploy things in there. What you will also see is that the new VCF CLI is plugin based. What that allows us to do is to create new functionality and integrate it really easily, because it's our CLI. So the first time I log in, it will automatically look at what kind of plugins do I need to install to be able to manage my workload. So it will just go ahead and install that. Okay, so that's all installed. And now we have access and created all the boundaries that we need to start deploying our workloads. So if we go back. Okay, we can start talking about how we're managing all of the services that we are bringing. I'll get this ready.
All right, so you've heard all the services, right? Once again, like we've kind of understood kind of the general model that's going to happen. So primarily the way we think about the supervisor is really allowing us to manage these resources, these configurations through one single declarative API. And that's a declarative API that is in every single ecosystem and it is identical. We think of this supervisor as a way to, like I said, bring an extendable service framework to be able to bring a ecosystem that is going to be able to grow. And we want to be able to have that new capability, that new functionality be discoverable by the consumers without needing to do any kind of evangelism, right? The second you enable that service, it should immediately be visible to the consumer. And using the supervisor, using VCF automation, this is actually possible. And the key thing here is all of these services, everything we're doing is being done through that para-virtualized model, meaning that we are abstracting away infrastructure and we are allowing for self-service in a safe, governable way. So these are just some examples of the services that we provide today, and this list is growing. Primarily, as we go into the demos, we're going to actually look at some of our embedded services, the things that are kind of behind the scenes. And then we're going to look at some services that we are going to upgrade through asynchronous mechanisms. And then we're going to look at even ones where it's like not there out of the box. I go download it from the support portal. I install it in the environment and then make it available to my consumers. And I think if you just understand that watch act model, the idea of these controllers and these operators, and then how they are leveraged, you're going to see all of this in action in the demo. So. All right, so the first thing we're going to do is we are going to go log in with cluster admin credentials into one of the supervisor control planes. I'll just say one thing real fast as a warning. Like you are like super admin here, okay? So when you go in, we're doing this so that I can show you what's kind of happening behind the scenes. A consumer will never see a lot of this. And you should be careful if you ever log into this ecosystem this way, you can cause irreparable damage to the platform. Just a warning. So we're going to log in. Once we're in, we can actually use kubectl just like we normally would. So if you remember like the flow that we were looking at in just normal Kubernetes, when we run a kubectl get nodes here, we're running this against the supervisor and suddenly we can see that we have these nodes. And these nodes are those 3 control plane VMs that I was talking about being deployed. We can do a get namespaces. So you're going to notice something. I want to call out a couple of unique things here. So we have lots of namespaces here. All of the namespaces that are prefixed with VMware-system, these are hidden. Consumers never see it. It's kind of the back-end secret sauce that is actually operating this ecosystem. Every single one of these is utilizing that model of operator custom resource definition. So we are having capabilities that are exposed to our API through a custom resource, and then we have a controller operator that is going to be responsible for lifecycle managing and making those things a reality. We also, towards the top section, we have the cube dash whatever. Those are also system namespaces, but those are primarily around standard Kubernetes operations. And then we will also see some namespaces here with the prefix of SVC. These are our optional services, so the things that we've installed in this ecosystem or we can upgrade and configure. And these are what we would typically refer to as supervisor services. And we would see these in vCenter. When we are actually going into vCenter, we can manage the workloads that are in here, and we'll take a look at that here in just a second. And in the kind of top section, we have like dev-21. that is actually a consumer's namespace. So here we can kind of see everything that is occurring from a namespace perspective. So if we do a kubectl get pods on, we're going to check out this VMware system VM op namespace. This is where our VM service operator lives. When we do this, we're going to see two primary deployments that are, or pods that are present here. We're going to have our VM operator controller, and then we're going to have the console validator. So kind of they play together to make sure that as operations are occurring, we are doing it in an acceptable manner. But the key here is when we do a get logs. So get logs is just the way that we can look at the pod runtime and see actually what's been executing behind the scenes. So just like any kind of other logging solution. And you'll notice that we have this, we have one log command here that says reconciling virtual machine. So we can go in here and we can actually kind of troubleshoot and get some visibility into exactly what this operator has been doing. But this is actually the event that was executed when a consumer requested a VM for their CLI operations, which is deployed in the inventory. You can see it over on the left side. So the operator is executing on the behalf of the user when that user requests a VM, a virtual machine object in the API. So let's look at, we looked at the controller. So like the next thing we should look at is what are the custom resources that are available to us? Like I said, custom resources are just API resources. So we can do a kubectl and get API resources, and we can, here there's going to be a lot. So we're going to do a grep for virtual machines specifically so that we can see the kinds of objects that are able to be executed within the VM operator's API, right? So once again, custom resource definition with APIs and kinds. This is going to be a reoccurring theme throughout all of these services. So you're going to notice that we have a whole bunch of different kinds: VM class, VM image, VM service, virtual machine resource policy. All of these are API objects that are exposed through this custom resource definition pattern that now I as a consumer can go leverage. So we can do a kubectl explain, and we can use explain on all of these API resources to get an understanding of what is what that object is designed for. We can also do some exercises around just doing a description of the actual API references, so we can see all of the different inputs that are possible in this. So you can almost think of it as like a Swagger-like API experience where I can go in, see what this thing gives me, and then what are the inputs that I need to be providing, what are the forms of those things. So in this example, we're looking at the virtual machine kind, and you can see it was a pretty simple set of inputs. So that was looking at a embedded service, a service that we aren't going to lifecycle on our own as administrators. It's just kind of there, it lives and shares the same lifecycle as the supervisor itself. But when we think about our VKS service, the VKS service is embedded. You'll notice that we have this 3.31-embedded. This is the version that just comes out of the box with the supervisor. But we also can asynchronously update this service as well, giving us the advantage of being able to have newer Kubernetes available to our consumers without actually needing to, once again, touch the infrastructure. So let's look at kind of what this life cycle looks like, right? Because it's very similar to what we're going to see in the rest of the supervisor service deployments. So first we're going to go and we're going to download. We're going to add a new version. So we're going to go download the new version of the VKS service. So recently we moved all of our service downloads into the support portal. So you log into the support portal, go to My Downloads, in the search bar type Supervisor, and you're going to look for that vSphere Supervisor Services folder. We're going to download this new version, which is 3.4. And once we have that package YAML downloaded, we now go back to vCenter and we're going to upload that manifest. At this point, we're registering this service version with vCenter. The concept here is that we register with vCenter in case we have more than one supervisor in this vCenter. So that way we can kind of reuse that manifest for other supervisor deployments. So this is kind of a two-step process. Register with vCenter first, and then once it's registered with vCenter, now we can actually go upgrade the actual VKS service that's running on the supervisor from 3.3 to 3.4. So we select the version, we select the supervisor. We're going to run some pre-checks. Once again, we're going to get the same warning, right? Because we're still running a single control plane. And at this point, we're going to be rolling out that new version of the VKS service. So when we see configured, that means the service has been successfully deployed, or in this case, updated. So now we're going to look at one more service installation that's important to understand. When we deploy, so you've seen a one-to-one kind of install here, right? We're on a vCenter, we're on a supervisor, we're installing a service. But I mean, let's be frank, like most of us operate much larger ecosystems. So like going to individual vCenters and doing this kind of install is going to be pretty repetitive. And we want to provide a better way to accomplish this task. Instead, be able to define a version of a service and then deploy it across the entire fleet of supervisors so that we ensure that as consumers are interacting with the system, they're interacting with like versions. So we're going to go to VCF automation. We're going to go into the provider portal. So this is where the admin, the cloud admin, is going to interact with it. And we're going to install a service through this mechanism. So in this example, we're going to use the secret store service. So we're going to go deploy it, and you can see we have two options: deploy to specific region or deploy to all regions. Here we're going to pick a specific region, so we're going to deploy it to our Paris region. We have one input that we need to provide, which is what storage class needs to be leveraged. And before we deploy it, just to kind of show you what is actually happening here, right? Remember, we did that get API resources. Here we're doing get API resources, and we're checking to see, do we already have the custom resource type of key secret vault, because that is the type that this new service is going to expose. So we haven't installed it yet. So you notice we do the grep, we don't get any inputs back. So we're going to go back and we're actually going to install the service. So we installed it. We can see that it's now successfully installed. So if you ever have a situation, we show this here because as this service is rolling out, you can go into vCenter, go into that supervisor service namespace where the controller is going to be deployed, and you can actually check on the individual health of the pods that are being deployed. And so if you ever run into a situation where you kind of need to debug or you're trying to understand why something's not deploying, you can go into this space, you can click on the view YAML link, and that will actually bring up a YAML file that's going to have a whole bunch of event details at the bottom. So it becomes a pretty powerful debugging tool to understand what is happening that's preventing the service from being deployed. So in this situation, the service has been successfully deployed. We can see that it's been configured. And now if we go back to our namespace, we do the same kubectl API resource and grep, we now have a new custom resource definition available to us. So remember I said when we add these services, the intent is I don't have to evangelize anything. As an admin, I don't need to tell anyone. It just shows up, right? Consumers immediately can see it in the ecosystem. So when we go into the consumer experience in VCF automation, we can see that now suddenly we have this secret service that's available. I can now go in and create a secret. And I create a secret. It usually has a name, and then that secret by name will have multiple key value pairs that can be specified. The secret service can store passwords, certificates, anything that you consider privileged, and it will be accessible to us at runtime when we actually deploy our workloads. And Katerina will show this here in a bit in a demo. So remember, we've seen that VCF CLI. The VCF CLI has a bunch of plugins that's available. And what we do is we typically auto-detect the context that you're utilizing, and we'll determine what services you currently are using or have access to. And we're going to automatically install some plugins. Here, we're going to go manually install the secret plugin so that we can then use the secret plugin for VCF to actually manage those secrets used in the VCF CLI. So we're going to install that secret plugin. So once it's installed, now I can do a VCF secret list, and I'll be able to see the secrets that have been created in my ecosystem. Can we take questions at the end? Yeah. All right.
Okay. So now let's see how we are using these services. So we're going to go and now deploy that application that I showed you in the beginning. And we'll go through the full deployment now. So this is now, as a consumer, I'm going ahead. Everything that has been configured for me, I'm going to start using it. So as I started with my 3-tier application, I am deploying a virtual machine, which will host my MySQL database. So I'm going to go through a flow, give my virtual machine a name, select the zone where I want to deploy this to, and select the image that's going to be used for this. So these are coming from those content libraries. I'm selecting an Ubuntu image. Now I'm going to configure my VM with resources. So I'm going to select a VM class that gives me 2 CPUs and 4 GB of RAM. And then I could do some advanced things, but for my application specifically, I need to expose certain ports. So I'm going to create a load balancer in here for this MySQL. And I'm going to add 2 ports. One will be 22, so I can SSH into the machine, and then 3306 for MySQL. So I'm adding those. And then I can do full customization of this virtual machine as well. So I'm not just going to deploy my VM, but I'm going to fully configure it. I'm going to create a user, I'm going to install MySQL, and I'm going to configure my database as well, all within this cloud config that I'm passing through during the first boot of the VM to bootstrap it with this information. Everything that I have requested is in here. So I've added that. I could change some networking information, but I don't need to. And now everything that I have defined in the kind of UI has been captured in my resource manifest on the right-hand side. So in there, you can see that all of the objects I need are there. So for a virtual machine, my bootstrap secret that has the configuration of cloud in it, also the load balancer that I am requesting. So what I can do now, because this has been captured as code for me, I can download this and we'll see later why this may be really helpful. So that's my VM. I'm going to go ahead and deploy that and just wait for that to boot up. That will be my database that I need for my application. Now, I need to capture securely how I'm going to connect to my database, and I'm going to use the secret store to do this. So I'm going to create a secret in here, and I'm going to use that VCF CLI to create this. So here's a manifest of the secret that I'm creating, and as you can see there, I'm defining what is my DB user and its name, what is its password, what is the database name that I'm connecting to. And this is something that I will be then injecting into my containerized workload to be able to establish that communication. So I'm going to use the VCF CLI to create the secret out of this manifest. And now my secret is created successfully. It's called dbcret. You can see it in there. If I list it, we can see it appeared. So I do have my MySQL database. I do have a secret. And now I'm going to deploy my Kubernetes cluster. So again, from a consumption experience, as you can see, all of the services are exposed in the same way. So also my consumption experience is exactly the same for all of the resources that I'm using. I'm going to deploy a Kubernetes cluster. I'm just going to give it a name. And I can select the version of the cluster that I want to deploy. And now this is directly related to the version of the service that Jeremy was showing you. Because he has updated the service to version 3.4, that has exposed the latest version of Kubernetes for me, 1.33. So I see what is available to me. I'm going to select the latest version here. If I want to, I can do some further configuration. I don't really need it for my cluster now. So I'm just going to go to the next step. Then I can define the control plane of that Kubernetes cluster that I'm deploying. So keeping in mind now I'm deploying a fully conformant Kubernetes cluster, a VKS cluster, so it will have its own control plane, its own worker nodes. Here I'm defining the control plane. I just need one replica for my control plane, and I can select the storage class and also operating system for my nodes. Now, for purposes of this demo, I'm just going to go with Photon. We also distribute Ubuntu. And if you would need for your worker nodes, you can also do Windows. So now I'm going to create the worker node pool. Again, just giving it resources. So again, selecting my VM class to configure it with resources, selecting my operating system, and I can, if I want to, I can also label it. So what I'm going to do here, I'm just going to create a label that basically says this is part of my 3-tier application. And now I can just finish. And again, the full cluster manifest has been created for me. So I can download it. And I can go ahead and deploy this cluster. So very easy to use. In the inventory, if I go to the namespace, just to see the back end of this, I can see my cluster is deploying there. I have the first control plane because it always starts with the first control plane. And then it will go ahead and deploy the worker node as well. So we're just going to wait for the cluster to be fully deployed. You can see now I have my worker node as well. Now it started. So once this is available for me, if I go back to this view, I can see my cluster is ready. Now, I need to do a few more things now because I want to be connecting to this cluster and deploying my workloads into it. So again, utilizing the VCF CLI, I'm first going to do a cluster list. This will give me a list of my cluster. I currently just have this one that I have deployed. So now, I'm going to create a service account and a token for it still on that vSphere namespace level that will be used to reach out to that secret store. This is what will be used to retrieve that information that I put in there. And you will see that this is the first step. When I will be inside of the new Kubernetes cluster, I will connect the link. So again, on the vSphere namespace level, I'm creating a service account and a token to be able to access the secrets in secret store. So I just have the definition again defined there. I'm going to apply this. So that's all created. Now, I need to connect to my Kubernetes cluster to continue. So to do that, I'm going to first register this cluster. And I need to create a context within the VCF CLI to be able to switch between the two. What that will allow me to do is that I will be able to switch context between the vSphere namespace and the Kubernetes cluster. So what I'm doing, I'm grabbing the kubeconfig of this Kubernetes cluster that I have deployed. And I will just take the context of that and create a context for my VCF CLI to connect to this. This is where I will enter the API token. As I mentioned, make sure when you create the token, save it because you will be using it all the time. Also, there's a refresh period, about I think an hour. So as you are working through the system, you may need to re-authenticate. So make sure that your token is handy and you keep it somewhere. And now that I have created a context for my cluster as well, I'll just refresh everything so I can see that everything is in place. I can see all the contexts that I have available. And now I can switch into the Kubernetes cluster. So you can see that I'm using VCF context use, and now going to my Kubernetes cluster. And then when I use my kubectl commands, they will be pointing to that context. So this is why it's important for me to be able to switch between the two, because I'm deploying resources in my namespaces, but then I also want to be deploying resources directly in my clusters. So I can create many contexts to be able to switch between. So now we're on my cluster. I'm going to clear this. And the first thing I'm going to do is I'm going to create a namespace for my application. So I'm just creating a new namespace that's called demo. And now I'm going to create a service account that I will deploy inside of this cluster that will be also pointing to a token that's connected to the account that we created on the vSphere namespace. And this is, again, that secure state where my Kubernetes cluster will not be the one reaching into the secret store directly. It will be going through the very secure supervisor layer. So there's everything we have implemented is always going through this model of supervisor being the only place that is able to reach into all of the secure locations. So I just connect the two. I'm going to apply that in my namespace. So now I have that connection created. I'm going to set my pod security policy to be able to deploy my pods into this namespace. So I've just labeled that. And now what I need to deploy is a vault injector. So the secret store is using OpenBow in the backend, and what it's going to do in this one is configure the vault injector that will be actually injecting secrets into my workload. So this is something we provide in our documentation. It's not something you need to come up with yourself. There are a few bits that I want to point out what you have to kind of configure. So first of all, I need to configure a connection to my secret store. So you will see there's a value that's defined, that's the IP address of my secret store. If you want to figure out what the IP address is, a very easy way is to go to that Supervisor Service namespace, and under Services you can see the IP address. So that's provided by the load balancer. So I'm going to grab that, go back in here. So that's the IP address. And now there are different configurations. So again, it's defining the deployment, it's creating service accounts to be able to reach into locations, roles, role bindings. We don't have to go through all of them. It's the full configuration of that injector. So I'm going to apply that. Okay, I can see that all of those resources have been created now. So now I'm ready to deploy my containerized workloads, but also inject those secrets into them. So let's look at my backend first. Again, we don't have to go through all of the configuration, but what I want to highlight is this section of that injection. So you can see that I have several annotations there for to define where this is going to go. So first of all, we do have a volume path. So this is where the secret will be injected. So you can see it's app vault secret. Then we're defining the file where this is going to get injected into, and also the kind of template that will be used to inject the information. So you can see I have there my DB name, my DB user, the DB passport. So all those values that I have created and stored in the secret will be injected into the file in this kind of format. And I also have the IP address to connect to my database in there, and also fronting it with a load balancer that's going to be used by the front end to connect into this. So I'm going to deploy this. And now, if I look at all of the resources that I have deployed in the demo namespace, you will see that I have my backend deployment, but I also have pod for that vault injector. So that's doing the role of injecting the secret. What I can do is I can use that exec command to look into the backend in here and go to that path and see in there, I see vault. If I go in there, I see secret and the file, and it has all of the values. So I can see that all the values were successfully grabbed from my secret store and injected into this pod. So now what I need to do is deploy the front end. So this is going to be providing the web UI. So I'm just going to quickly deploy that into the same namespace. And now that we have everything deployed, we'll just wait for the service for the front end to get an IP address, and we can then use that to access our application. So I'm just going to go in a browser to that IP and the port, and this is our very simple sample application where I can go and register a new user, and this will be written in the database. I can then use the user to log in, and I can go ahead and write something into the database. So the way the communication works, we have established that everything is working correctly because all of these entries are coming from the database. The backend is the one doing the communication between the database and this web frontend, so we know that is working. And because we can connect to the database, we also know that those secrets were injected correctly as they were supposed to. So we know that this application is now working and everything is deployed as we want it to. And that brings us to our last topic. If we I'll quickly switch. And that is one of my favorite topics to talk about. And that is how we have basically unlocked GitOps in our platform by introducing Argo CD service. So everything we have done so far was great. We have manually created our application, deployed objects, but we now want to take it a step further. And we want to take all of that code that was generated for us automatically, store it somewhere securely, version it, and then use something like Argo CD to do the continuous delivery of this deployment. So we're going to do a demo of that. And I do want to show you the full process. We have just about enough time. So first of all, I'm going to introduce the new service into the ecosystem, following exactly the same pattern as we have seen before. So I have grabbed the YAML definition from our portal. I have now registered it with vCenter. So the service is now registered, and I can go ahead and install this. What is this deploying is an operator for Argo CD. So you will see in a minute when I deploy this. I don't have to provide any additional information. I just deploy this. And then if I will go to that Supervisor Service namespace, specifically for Argo CD, we will see that it has been deployed. So what this means is that this is my operator. Now, this is something the cloud admin would enable and allow consumers to then go and deploy their own instances of Argo CD. So once this is running and there, I can switch back to my CLI. I'll go back to that context of that vSphere namespace where I'm deploying my resources. And again, I can use that explain command to explain this new resource definition, which is Argo CD. So this will give me, again, information about exposing what is available to me, how does it work. I can even go a step further. And for example, if I use the same command but go into spec version, I can see which version of Argo CD, for example, I can install. So I can see that's there. So now I do have a very simple definition of my instance. All you basically have to provide is a name and the version. So I'm taking the version I've seen, defining it here. And now I can go ahead and deploy this Argo CD instance. And just make sure that everything is running as it is, so that's all good. And now I can get, again, it's fronted by a load balancer, as you will see. Again, very common pattern. We were trying to access something externally, so we need to front it with a load balancer to get an external IP. So I'm getting that here. And when you deploy Argo CD instance, it comes with admin password and this default secret, so we can grab it out. And then I can log into this instance using that password that I have just taken out of that secret. The default username is admin. But because I don't want to remember what that is, once I'm logged in, what I can do is change this password for the admin user. So this is very useful. So I'm just going to go ahead and change that initial password for something that I can remember and actually type in later. Okay, so my password is now updated. And now what I'm doing here is I need to make sure that Argo CD recognizes my supervisor as the target for the deployment. So I'm adding that as a cluster, and I'm also adding specifically that namespace as well. So I will be able to deploy workloads into the namespace. As you can see, this automated process is creating all of the necessary service accounts and role bindings to allow this to operate. So now if I grab the IP of Argo CD server, I can open it in my browser. And I can just log into this. So this is my brand new instance. Once I log in, you will see there are no applications in here. Now, I'm not going to go through all of the details of how Argo CD works, but I will show you how I can now go ahead and deploy everything that we've seen before. And the way we do that, again, the whole idea is that we can take everything defined as code natively in our platform, as we have seen all of those manifests that have been created for us, and create a Git repo with all of these files. So in here, I do have a full structure for my 3-tier application. It works on a pattern of an app of apps. So I do have a parent application that defines all of the resources, all of the other child applications that I will be deploying. I'm going to grab that. But what I do want to show you is that in my definitions, for example, if I go to my VKS cluster, you can see this is the manifest that we have generated in the UI. So that was also the reason why I was downloading all of the files. It's very useful because you can go through the UI, download all of the spec that's created for you and just like place it in your repository. So that's just an example of one of them. But now I can take that parent application and create it. So you could do it in the UI, or you can, again, use a YAML manifest, which is what I have saved. So I'll do that. And in here, you can see that it's the source is the repo that I'm pointing to, and the destination is my supervisor and specifically the namespace in here. I'm just going to create that. And this will then go ahead and deploy all of my applications. So I have it separate in sections because I want to be able to deploy this in specific waves as well. So now that I have everything deployed and ready, what this means is that all the desired state that I have defined in Git is matched to my platform. So all of the resources are there and deployed. For example, if I find the resource of the front end of that application, I see my application is accessible again. But I just want to, as a very last step, I want to show you one more thing, and that's the continuous delivery is all about continuous delivery. It's not just about the initial deployment, but every time I want to make changes to my application, I don't have to go and do it on the actual resources. I can do it in my code. So for example, the cluster we were deploying, if we look at the manifest, we remember we deployed one worker node, so I have one replica stated there. Now, if I've decided to have two, all I have to do is change my code. And I can also commit it with a proper message, and I will have versioning, and it has all of these benefits, why I would want to do that. So I'm going to change that number to 2. And if we go back in here, we will see that Argo will pick up the difference and start syncing that cluster again. And I also really like the way Argo CD displays really nicely visually all of the components and how they connect to each other. So for example, our node pools that are listed here, we can see that currently in the desired state, it's already matched. So it's showing that I want 2 replicas of this, but it's now progressing because it needs to go ahead and deploy that second worker node. So if we click on that, we can see that it's waiting for resources to be ready. On the infrastructure side, if we just look at what's happening, we will see that another worker node is currently being deployed. So again, I did not have to touch anything. All I did was make a change in my code. And after a while, I can see that it has synced. And again, my application is now fully ready. So that was the last bit of the demo. And we can switch back to this. So what I showed you in the beginning, we've done exactly the same thing, but we have introduced yet another service, which was Argo CD, to do all of this. So this was just a demonstration of how we can use all of the cloud services that are provided by VCF and combine them to really provide this ecosystem for our applications that is not just about deploying those virtual machines or classes, but actually reaching the end goal of everything that our applications need. And the next steps are really all about you. If you can, please go and try to deploy this in your environment. Work with this, please provide feedback. If you do want to get some hands-on experience, we also still have a hands-on lab called Managing Kubernetes and Cloud Services on VCF that you can go and take here as well. Later on, they will be published. So most of these concepts we will be covering in that hands-on lab as well. And with that, thank you very much. Please take a survey. Thank you for staying with us for 90 minutes. I know that's a very long time, so appreciate your attention. If you do have any questions, please feel free to ask, either now or we can stay here. Have a nice rest of the conference.
And real fast, like I'll be at the hub in the demo booth until 6:30 today. So like feel free to come by, and if you have any like burning questions and want to see more about what's actually happening under the covers, like come talk to me.